So I'm making you the host, sir, and then you can start the mid session.
Okay, all right.
Done, sir. Over to you.
All right. Okay, guys, again, I would like to welcome you all. This is day one for the course, and we are here to learn Linux, Ansible, and OpenShift, right? So in the demo session, a couple of days back, I explained the objective of this course. What are you going to learn? And after learning Linux, Ansible, and OpenShift combination, where you can apply, I mean, what positions you can apply, right? Okay, so let me just do a quick recap and then we'll jump into the first step, which is create a virtual machine on your laptop so that you can start practicing, right? Starting from day one, you can start practicing. Okay, so let me just open the introduction PPT. So in the demo session last time, I gave you a brief introduction to all these three technologies. For example, the first one, Linux operating system. So Linux operating system is always the step number one, no matter if you talk about DevOps, if you talk about SRE roles, Linux is the step number one. Okay, even as a Linux administrator, Linux with Ansible automation or some automation skill is required. So that's why Ansible is the second step here. So in Linux, we are going to learn like the core technology, like how Linux operating system works, what are the fundamentals, the architecture, various commands, user management, process management, application management, storage management, application management, all those things. And then we'll uh, take it a notch up by automating everything. So whatever we learn in Linux, we are going to automate all those things with the help of automation, with the help of Ansible automation tool. So uh, by automating, I mean, let's say you have 200 Linux servers and you're supposed to update all the 200 Linux servers within 2 hours. Let's say Saturday morning, 11 a.m. till maybe 1 p.m. Okay. Okay. So in this time window, this is called basically maintenance window. So in this maintenance window, you will be asked to update the servers. Obviously it will be planned activity. It's not going to be like someone calls you and asks you to do that. No, it's going to be a planned activity. Okay. And in that case, you will be if you don't know automation, you will be doing it manually. So 200 servers in 2 hours window, not possible. But if you know Ansible automation, you can do that. Okay, you can schedule the automation to automatically update the servers, or even you can launch the automation on ad hoc basis on demand, which will again do the same thing, update multiple servers all at once. Okay, it's not like one by one. Multiple servers will be patched or will be updated via Ansible automation. Okay, so the fundamentals of Ansible, how it works, uh, how to use Ansible, the architecture, how to set it up, your lab, practice, and what are the various components in Ansible that you should be aware of before we move to OpenShift. Okay. Then the third one, OpenShift. So when we talk about DevOps, uh, what exactly is the in the center? In the center is the application development. So the developers, the coders, they design the application, they code the application. Okay. And when I say application development, it's not a one-time job, it is a recurring job. Okay, so if there is an application development team in your organization, they will start with a prototype, then they will release it, let's say version 1. After a few months, there will be version 2, version 3, version 4, and so on. For example, in your hands, you have your mobile phone, right? Maybe Android, iOS. What version is it? Android 16, 15, 17, not 17, but yeah, 14, 15, 16, right? So what's happening here? Android operating system is evolving every year, right? Some enhancements are introduced, flaws are fixed, security loopholes are fixed. Okay, some UI changes and all. The same thing happens around the world with every piece of software. Okay, so when the software is constantly evolving, there has to be a mechanism to make sure that the changes in the software are being tested thoroughly. Okay. So testing teams are involved, quality assurance teams are involved. And then before moving the code or moving the application to production servers, again, some steps are performed. Okay. So ultimately, the application is in the center. And where is this OpenShift? I mean, in the picture. So when the application, let's say the application is now containerized, okay, mostly the applications are now containerized in the enterprise. I'm not talking about the mobile apps and all. Okay, so in the companies, the applications are containerized. Once the container is built, then what? Then the container has to be deployed not only as one container, but as a cluster application. Okay. And then that cluster application has to be managed, auto healing, auto scaling. All those things need to happen automatically. Load balancing need to happen automatically, right? So this is the place where OpenShift comes into the picture. Okay. So when we talk about application as a container, containerized application, okay, so container is one topic. Containerization or containers is one topic, followed by Kubernetes. Okay, so Kubernetes is that management system which will help you manage the containers, the life cycle of the container. Okay, so the Kubernetes engine is going to help you manage the containers. Now, around Kubernetes, when enterprise level security and some enterprise level features are applied, this whole package becomes OpenShift. Okay. Red Hat OpenShift allows you to deploy containerized applications, manage with Kubernetes, and have a kind of a dashboard where you can manage everything. Right. So this is the power of OpenShift. If you are applying for any organization where applications are being developed, okay, so they basically need someone who knows how to handle the flows, the CI/CD and all with OpenShift. Okay, so we'll be exploring all of these things. When we talk about the practice, we'll be practicing Linux on a virtual machine. Okay, we'll be deploying Linux on a virtual machine. Similarly, Ansible, we'll be deploying it on a virtual machine. OpenShift, we have various options. You can deploy it on a machine, virtual machine, on the cloud, or even Red Hat offers a practice environment called Sandbox. You can have a sandbox trial for 30 days, and you can practice OpenShift on that sandbox, and that trial can also extend beyond 30 days. Okay, I'll tell you how to do that. Right. So this is the objective of the course. Again, as I said, I explained many things about all these topics in the demo session. Okay, so what I'll do is I'll be sharing all this course material in advance with you on a Google Drive. Okay, so tomorrow when we connect again at the same time, I'm going to share a link, Google Drive link, and you will find the material for Linux first of all, because we are going to start with Linux. So you'll find the material for Linux, the PPT that I'm going to use to deliver the course, the topic Linux, and the daily notes. Like on daily basis, when I'm delivering the class, I'll be using this notepad and I'll be saving this notepad in the Google Drive notes folder. Okay. So you can pick it up from there. And the third one is the related ebooks. So ebooks related to Linux and uh, maybe some bash shell scripting. So as we proceed, I'll be introducing you to all of those ebooks. So the course material, the learning material will be available on the Google Drive, which I'll be sharing by tomorrow. All right. Okay. There is a chat. Okay. So am I going to teach CI/CD? Yes, obviously it's part of the course. Am I going to teach Jenkins? Officially, Jenkins is not part of the course, but don't worry. I'll be explaining Jenkins, how to set it up, how it works. Okay, not a big deal. Right. So when we reach CI/CD, just remind me. Officially, it's not part of the course, but yes, you can. It's, as I said, it's not a big tool that you need extra 10-20 hours. So Jenkins can be learned easily. In fact, we'll be performing some labs also with Jenkins. Okay, so that you have some hands-on. All right. Okay, and as I said, once you are done with this course, you can easily get into these profiles. Linux admin, which I don't recommend. Obviously, you know OpenShift. Why would you go into Linux admin? But still, if you think that you're not getting calls and you're in desperate need of job, Linux admin will be the easiest way to get into IT. Trust me. Okay. Because when you apply as a Linux admin with automation skills, with OpenShift skills, they will beg you to join their organization. Trust me. As a fresher, it's a big deal to learn, OpenShift, automation, and Linux as a fresher. But if you are, let's say, experienced, then obviously there will be a bit of competition, and then it depends on your on your practice and all, like how much do you remember the concepts and all. Okay, if you're able to clear the interview. And obviously, with every topic, we are going to practice the questions, the interview questions, and the exam dumps as well. We are going to practice those things, right, so that you have a bit of confidence. Okay, so Linux admin. Next is automation engineer. Again, as I said, with Ansible skills, you can be automation engineer in any organization. Ansible automation, which where you will be handling automations on Linux servers, Windows servers, cloud environment, maybe storage servers, because Ansible is versatile. You can use it to perform automations on any platform, any device. Okay. Likewise, platform engineer. Guys, just a second. Okay. Next one, platform engineer. Platform engineer, again, it's directly related to OpenShift because it will be the core. And as an OpenShift administrator, your responsibility will be to manage the life cycle of the containerized application. Okay, not only the deployment and all. In fact, the cluster deployment, the cluster management, everything. Right. Then the last one, site reliability engineer. Now, for this profile, you need to have at least 5 to 7 years of experience. Okay, at least 5 years of experience, and you need to be aware of how things work in an IT infrastructure. Okay, like applications uptime. The application should be 99.99% up throughout the month, every month. So how will you maintain that? Okay, so these are like service level agreements, SLAs, SLOs, and all, right? How to respond to incidents and all. So as a site reliability engineer, your job will be, at the you can position yourself above the developers, administrators, okay, and somewhat equal to the architect. Okay, so here again, as I said, you need a bit of experience, minimum 5 years, and with OpenShift skill, OpenShift, Linux, Ansible, you will be able to crack through, right? Okay, so now let me start. Okay, there are a few more chats. Okay, so Rishi is asking, are we going to do EKS? We are going to cover the Kubernetes, yes. Okay, if you want, we can practice Kubernetes, the deployment on the cloud. Let's say on AWS, we can do that. It's not a big deal. It's just one automation away. Okay, I'll show you how it is done. It's very easy, right? Guys, just a second. Okay, all right. So on AWS, normally we use Terraform, okay, to deploy EKS, or the cloud native, the AWS native commands. We can do that. Okay, so I'll show you. I'll make sure that this is part of the lab so that you also have hands-on on the cloud, right? And the second question, does networkkings provide their own labs for OpenShift? See, I think this can be done, but this will be charged extra. More details can be shared by the consultant. You need to contact nwkings team. They will help you with the charges and all. Okay. All right. But otherwise, as I said, if you want to practice OpenShift, there are these many ways. The developer sandbox, I hope the screen is visible. The developer sandbox, you can just request access to developer sandbox on trial basis. It's free of cost for 30 days from Red Hat. Okay, so you will get a pre-built lab. You don't have to install anything. You simply start working on OpenShift, or locally you can install with the help of CRC. Again, the methods are available on Red Hat OpenShift.com. Okay, OpenShift.redhat.com. Okay, for local practice, make sure you have at least 16 GB of RAM. That is the minimum requirement. Okay, because out of 16 GB, you will be allocating 9 GB to a virtual machine. And that virtual machine will act as the master node and the worker node, and everything will happen in that one single machine. Okay, yeah, you can practice that way as well. Okay. All right, so let me go to the Linux PPT. Hold on. All right. Okay, guys. So before I proceed, in the chat, let me know how many of you know about Linux operating system and the level, like beginner level, intermediate, advanced, so that I have an idea about my audience. Okay. Can you just quickly tell me in the chat the skill level around Linux? If you don't know anything about Linux, no worries. Just say new to Linux. Otherwise, just say beginner in Linux, intermediate Linux, or advanced skills like that. Okay, new to Linux, new, intermediate. Okay, Shaji. Okay, good, nice. Bashir is advanced. Good. Okay. As a network security engineer, but new to Linux and want to get into automation. Perfect. New to Linux, perfect. Okay, never mind. So, as I said, I need to know my audience first before I start with the topic. So, accordingly, I'll be starting, which means starting from the scratch, the evolution of Linux, um, the idea behind Linux operating system, why it is popular in the IT world, and how it functions, right? All those things. Okay, so one more network security engineer wanted more into. Okay, so as a DevOps engineer, yeah, so perfect. All right, so again, as I said, let's start from scratch. So the basics, first of all, the origin of Linux operating system. Okay, even before that, what is an operating system? So let's talk about this. Uh, Again, the today's objective is that we should be able to create a virtual machine. Okay, so we'll start with the basic stuff. We'll get into uh, how to create a virtual machine on your local laptop, on your desktop, laptop, whatever you're using. Okay, and then so that we are ready for the practice, right? Okay, so what is an operating system? Operating system is a software, right? It's a big software that manages computer hardware, software resources, and provide common services to computer programs. Right. So again, in your phone, Android, iOS, these are all operating systems. Okay. And what are the functions of an operating system? Common functions. First is the management of hardware. Okay. Hardware like what? Motherboard, RAM, processor, hard disk. Whatever is connected to the motherboard, that peripheral device included, everything has to be managed by the operating system, right? Second is memory management. Memory means what? Memory is not storage, not the permanent storage, hard disk, or maybe external pen drives and all. Memory means RAM, random access memory. Okay. So every device needs a memory to synchronize with the CPU. CPU runs very fast in gigahertz. Okay, like 2 gigahertz, 3 gigahertz, compared to the hard disk, which runs in megabytes, 100 megabytes if it's a normal hard disk. SSDs, maybe 500 megabytes per second, or NVMEs, let's say 4 GB, 5 GBs per second. Okay, but still, 4 GB, 5 GB is not equal to 3 gigahertz, 4 gigahertz speed of a CPU. there is a speed gap. Okay. To bridge this gap, RAM is required, random access memory. RAM can talk to the CPU at its own speed. RAM can talk to hard disk at its own speed. This is the benefit of RAM. Okay. And without RAM, system cannot boot up. The downside here is RAM is not in abundance. RAM is expensive. You can have 1 TB hard disk, 2 TB hard disk. Okay. It's not that expensive. You can buy it. But when it comes to RAM, on a laptop, I'm talking about, or a desktop, you can go up to maybe 32 GB. These days, 32 GB is like 40,000 rupees, Indian rupee, right? Because of the, shortage of RAM, and the other things, other components, because of the huge orders for AI data centers, right? Okay, so 32 GB versus 1 TB hard disk. Okay, okay, forget about 32 GB. Maybe your laptop has 8 or 16 GB RAM, but you have still 1 TB of hard disk. Okay, so if you compare the cost of the RAM and the hard disk, there is a big gap. Okay, you cannot have a same capacity RAM as the capacity of the hard disk. Okay, so let's say 16 GB RAM or 8 GB RAM. Okay, so your system is going to function properly with that limited 8 GB or 16 GB space. You are able to launch heavy applications, maybe some games, maybe photo editing apps or video editing apps, maybe Adobe Photoshop or Premiere Pro, or I don't know, DaVinci. Okay, so if you're into these things, right? So how it is happening? Operating system is managing it. Okay, operating system makes sure that sufficient RAM is available for the launched application, and also the support of multitasking. Okay, so next point is manage multitasking. Multitasking is only possible when good memory management is happening at the OS level, right? You can run multiple applications. Like you can see, I'm running one PPT, as well as browser is running, my Outlook for emails, okay, one terminal to run the commands on my Windows or Linux operating system, right? So multi thing, even I'm delivering this class on Zoom, and this class is being recorded or being streamed live on YouTube, I don't know. So how is it happening? It's happening because operating system is able to manage all of this, right? Next is managing multiple users. On a normal laptop, desktop, it's you who log in. Okay, but on a server, there may be 10, 20, 30, 40, 50, maybe 100 users logged in parallelly at a time doing their own work. Okay, so operating system has to manage all those multiple users sessions. Okay, then process management. What is happening in the operating system? uh, you might have experienced a situation called deadlock, or in a layman terms, if I say the system is in hang state or hung state, it's not responding. So what's happening? Some processes are in deadlock state. Okay, so operating systems basically track all of this, the process management and all. They make sure the processes get ample amount of CPU time for execution, and they exit the RAM on time, because when the process is running, it is using RAM. Okay, when the process job is done, it will exit the RAM. It will leave the space which it was occupying. Operating system has to manage everything. Okay, and then error handling and logging. That is the last part. Error handling and logging. It's like, you know, let's say on your laptop, there is the operating system, some installed applications, and obviously the hardware as well. All these components time to time generate a message. For example, you turned on the Wi-Fi. The message will be Wi-Fi turned on successfully. Then you connected to a network. The message will be connected to so and so Wi-Fi network successfully, right? So these messages are captured by the operating system and stored in files. Those are called log files. Those messages can be some sort of notice, information, notice, or error, warnings, critical errors, critical warnings, like that. Not critical warning, but critical errors, fatal errors. There are some priorities associated with those messages. Okay, as I said, message can be info, debug, or just a notice, or just a warning, or some error, like that. So whatever it is, that will be stored in a file called a log file. Those log files, again, hardware, software, all these components are going to generate these messages. And these log files are then analyzed during the troubleshooting. Maybe let's say the system is not performing as expected. Maybe some application is not performing as expected. You would want to find what is causing this problem. You would want to find the error. Go to the logs, you'll be able to. Okay. So in Linux, this topic Linux, we are going to cover all these things. We will see how to check the logs, how to analyze the logs, how to find the root cause and fix. Okay. So once we are done with the fundamentals, then we go to the application management, and then we go to the logs, and then we'll see what's happening, what details are captured in the logs. Okay. All right. Next one. Just give me a second. Okay. All right. So origin of Linux operating system. See, in 1990s, around that time, Unix operating system was developed by Ken Thompson and Dennis Ritchie. Dennis Ritchie is the father of C language. Okay, C language, the programming language. So Unix operating system was developed in Bell Labs, Bell, Bell Labs, by Ken Thompson and Dennis Ritchie. And this operating system was based on C language, Unix. Okay. Now in 1960, I'm talking about operating system with security model, with communication tools like emailing, automation tools like shell scripting, multitasking, multi-user support, all of these advanced features in 1960 in an operating system when computers were as big as a room, a big room. They occupied big rooms, not like, today's, laptops and all. Computers at that time, they were really, really big. Okay. And the operating systems were also designed in a way to make use of that hardware. All right. Unix offered these advanced features: multi-user support, multitasking, shell scripting for automation, security, portability, communication tools, process tracking, everything. Right. So it was really popular at that time. It was obviously users, the companies need to pay a fee in order to use Unix operating system. The downside was this Unix operating system was not, the source code was not available. Okay. It means it was closed source. No one knew how it is working. All they knew was C language. C language is used. But how things are working, what is the program, what are the program files? Okay, so they didn't knew about the development. I'm talking about the developers in 1960, those who were learning programming, or those who were learning C language at that time. Everyone wanted to, get their hands on to the source code of Unix operating system. Okay, and because of that, there was a kind of a race. Who will build a clone of Unix operating system, right? So because of this, curiosity, many developers, individual developers and group of developers tried to kind of replicate Unix operating system. Okay. So there was another developer by the name Linus Torvalds. Okay. And he was learning computer science at that time. And he again got really impressed by this operating system Unix. And then he decided to work on this as a hobby project, try to clone it. Okay. Try to clone Unix operating system in its own way. Okay. And just work it as a hobby project. So in 1994, he released the first version of the operating system he developed, and he named it Linux. Okay. So Linus Torvalds is the name, right? And he was working on Unix operating system clone. So he gave the name to his hobby project as LIN from his name. Okay. Linus from his name LIN, and UX from Unix. So this is Linux. operating system. Okay. So initially he released the kernel of Linux OS. What is the kernel? Kernel is everywhere. It's in your Android operating system, iOS operating system, Windows operating system. Kernel is that component of operating system which communicates with the hardware. Okay. Kernel knows how to talk to the hardware. So this kernel was developed by Linus Torvalds in 1994 and released as an open source project. Okay. As an open source project, it was released. Open source means what? It means the source code is available for free. Okay. So there are some rules of open source, which means if you are downloading some open source software, you will be able to access the source code. You will be able to modify the source code, rebuild the software, rename the software, and distribute it for free, and keep the source code again available for the users. So this is the power of open source. Okay. And this is the reason there are so many Linux operating systems in the market. Red Hat Linux, Ubuntu Linux, SUSE Linux, right? Okay. So this was the main thing here. This Linux kernel was open source. In fact, if you want to check it out, just search on Google Linux kernel download. All right. So on GitHub, you'll find the source code for the latest version. You just click on it. So he is Linus Torvalds. You can see here, he's Linus Torvalds. Okay. And this is the master branch. Let me check for the tags. Okay. So they're working on version 7, Linux kernel version 7. As you can see, release candidate version 2. Okay. And you have these files. These are the source code. Let me get into any one random folder. Just open any one random file. So this is the file, source code file. It is called C group-v1.c. And what is this? If you know C language programming, you'll get to know this is called header. Okay. Include header files. And then there will be a main function. They're defining a what do you call it? Function. Okay. Some static variables. Okay. And some if conditions, a loop. This is a loop for each loop. Okay. So what is happening here? It's all source code. Programming is happening, right? And if you just scroll down completely, it's like 1372 lines of code. Okay. And this is just one file. There are so many files, hundreds of files in this project. Okay. So with open source, what happened to this Linux project? First of all, many developers around the globe joined this project as a contributor. You can also see how many contributors are here in this Linux kernel project on GitHub. So here's Linus Torvalds. Let me open the Linus project code. Yeah. See, number of contributors, more than 5,000 are active, but otherwise more than 17,000 contributors are here added to this open source project. Okay. So these contributors are highly skilled developers, specialize in operating system development, and their job is to improve Linux kernel. Their job is to enhance Linux kernel. And if there is a vulnerability or security loophole identified, fix it. So these many brains are actually active on this project, more than 17,000. That's why whenever there is a security loophole or some protocol vulnerability detected, that is immediately fixed on the Linux kernel. Okay. Whereas if you compare that development or compare this progress on any other operating system apart from Linux, it will take time, because I mean they have a series of first of all, the resource limit. I don't think they have 17,000 constantly working on a project. Maybe some few, yeah, but not 17,000, right? So these many brains are actively working. Okay. And based on this Linux kernel, operating systems are derived. In itself, this is a mini operating system with some basic commands. So, because of this, the feature open source, and the speed of development. Many companies got interested in developing their own operating system, like Red Hat. So Red Hat saw the opportunity. So Red Hat was the idea behind Red Hat as an organization is to pick up the best open source softwares and commercialize them, or not commercialize, but add some security features and prepare them for enterprise use, prepare them for the servers in the companies, right? So Red Hat as an organization picked up this Linux kernel, okay, added some security features, some enhancements, new UI, and released a enterprise level operating system. So, and they called it as Red Hat Enterprise Linux. Okay. All right. So Red Hat Enterprise Linux is the product. Right now, the current version is version 10. And let me tell you, we are going to learn RHEL 10. Okay. Likewise, just like Red Hat, another group of developers like CentOS did the same. What they did is CentOS used the source code of RHEL. Okay, so yeah, they used the source code of RHEL, and they provided a operating system by the name CentOS. Okay, same name. Okay, with Red Hat, there is one thing that it is meant for the enterprise, for the companies. Here, companies need to pay for the support and timely updates. Okay, but CentOS did one good thing. They said there will be no support from CentOS as a vendor, as a company, but the updates are free. Okay, so free updates, no support and free updates. Right. So CentOS became a popular choice among the startups or small organizations where they cannot afford to pay, the subscription fee for the Red Hat Enterprise Linux operating system. Big companies can. Okay, obviously big companies can. Let's say in a startup there are like 100 Linux servers deployed, 100 virtual machines maybe. You need at least 100 licenses, 100 subscriptions. So each subscription is around 300 USD. Now calculate. That organization need to pay how much of money every year. So this subscription is for 1 year, right? So they need to pay this money every year. Okay. So if they cannot afford, they simply go with the alternative, which is CentOS. Although there is no support, they need to hire extremely good Linux administrator with extremely good troubleshooting skills, all right, so that they don't get stuck in some problems. Okay, and they get updates for free. Okay, so till CentOS version 8, it was like this. CentOS could be used on production servers because it is, again, using the same Red Hat Enterprise Linux source code till version 8. Okay, it is stable. It is for production servers. Okay, but what happened is Red Hat acquired CentOS, and then they said we are going to use CentOS as our test operating system. Don't use it on production servers. Then all the startups were like, now does it mean that we need to pay this much of fee every year? Red Hat said no, don't worry. What you can do is you can get 1 year free subscription, okay, which you can keep on renewing. Okay, so keep on renewing this. So 1 year free subscription. This is called Red Hat in subscription for individuals. And with this 1 year free subscription, you can run 16 virtual machines. Okay, or we can say this 1 year free subscription will be tagged to one user ID, username, and that using that username, you can run 16 virtual machines. You can install a Red Hat Linux operating system on 16 virtual machines, register with Red Hat, and get timely updates. Although the support is again not available. It is there will be no support, but yes, free updates, which means you can still use Red Hat Linux operating system. As a fresher, as a student, will be following the same procedure. Okay, download Red Hat operating system, register as a developer so that we get 1 year free subscription, and we start practicing Linux. Okay, if you want to try CentOS, you can do that. CentOS Stream is the new name. Okay. It is now called CentOS Stream. Latest version 10. Okay. So if you want, you can also download CentOS Stream version 10 and create a virtual machine and start practicing. Right. Okay. And so these are the all features of open source. Okay. Just read it out. I'll be sharing this PPT again in the Google Drive. So by tomorrow, I'll be sharing the link. Okay. All right. And remaining, there are many more things about Red Hat. Let's start with the main part, which is install the Linux operating system on a virtual machine. Okay. To create a virtual machine on your laptop, firstly, do this. Go to the task manager. If you're on a Windows laptop, go to the task manager and check the resource usage, the CPU and the RAM usage. Okay. Click on performance. Okay. So click on performance and click on CPU. As you can see in my laptop, there are 16 logical processors. 16 logical processors, good, which means I can easily allocate 2 logical processors to my virtual machine. Okay. If you have 8 logical processors, still it is comfortable. You can allocate 2. If you have 4 logical processors, which I don't think, but still you can allocate 1. Okay. So if you see 4 logical processors, allocate 1 CPU to your virtual machine. I'll show you how to do that. If you have 8 logical processors, allocate 2. I have 16, I'll be allocating 2, or I can even allocate 4, doesn't matter. Okay. Then same way for memory. Since I have 32 GB, I have available 16 GB. In your case, if it is like 16 GB, you will see available maybe 8 GB or maybe 5 GB. Okay. How much is required? We just need minimum 1 GB, maximum 2 GB. If, like in my case, I have 16 GB available, I can easily allocate 4 GB to the virtual machine. Doesn't matter. But in your case, if you have like 16 GB, go with 2 GB of RAM. If it is less than 16 GB, like 8 GB or somewhat like that, go 1 GB of RAM. Okay. On the MacBook, how do you check for the resources? I think you can go to your system about and check the processor and all. See, you are safe if you are on Apple Silicon, Apple M1, M2, M3, M4. If you have Apple Silicon, those are already 10 cores and all. So don't worry about that. Okay. And I'm sure you will be having minimum 8 or 16 GB RAM on MacBook. Okay. Yeah. So if it is M2, perfect. Right. Okay. So you're again good. All right. So now for the Windows laptops users or Windows users and Mac users. So let's see how to create a virtual machine. For the Windows users, the easiest way it is install VMware Workstation. Okay. So why am I suggesting VMware Workstation? Because most of the audience is freshers in Linux. I mean, beginner in Linux. They don't know about anything about Linux. Okay. So VMware Workstation is the easiest way to deploy a virtual machine. Okay. It is intuitive, less bugs as compared to other alternative like like Oracle VirtualBox. Okay. Although this is one more alternative. Okay. Again, it is free. VMware Workstation Pro is the name. Earlier, it used to be a paid software, but since Broadcom acquired VMware, they have just released VMware Workstation Pro as a free tool. Okay. Only prerequisite is register on Broadcom support. Okay. Register on Broadcom support page. Okay. And that's it. Once you are registered, you log in and then you can download VMware Workstation Pro. Similarly, on Mac, from VMware, there is another tool by the name VMware Fusion. Okay. Okay. The same story. VMware Fusion earlier used to be a paid software, but again, as the VMware got acquired by Broadcom, Now VMware Fusion has been released as a free tool. Prerequisite is the same, register on Broadcom support, and then you can download VMware Fusion application on Mac. Okay. All right. Okay, so let's go to this first step. Okay, let me just summarize all the steps. So the first step was to install the application using which you will deploy the virtual machine. So VM virtual machine platform. Okay, so install the application. This is the step number one. Step number two is acquire the installer file, operating system installer file. We call it ISO. Okay, so download the ISO file. Okay, so if you want to try or if you want to practice Linux on RHEL, we will log into developers.redhat.com. Okay, but if you want to try, if you want to learn Linux on CentOS, we just go to CentOS.com, CentOS.com/download like that, or download.centos.com. We'll see that. Okay, so RHEL from developers.redhat.com. Again, here you have to register and then log in. Once you register, you will also get 1 year free subscription. Okay. And then you log in and then you download the ISO file. Here in CentOS, no login, nothing. You simply download the file. Okay. And please note, this ISO file is going to be around 10 GB. So depending on the internet speed, internet connection speed, it will take the time. Okay. All right. So, okay, one more thing. Is it mandatory to install VMware Workstation or VMware Fusion? Let's talk about Windows. Is it mandatory to install VMware Workstation? Can't I install Linux without this workstation application? Yes, you can do that. That is called WSL. In fact, in the introduction PPT, I gave that idea. Let me go to that slide. Yeah, you see this, how to ways to practice Linux. One is called WSL version 2. Next is UTM. It is on. It is for MacBooks with Apple Silicon. UTM. Okay, so it's an alternative to VMware Fusion. Okay, then VirtualBox, Oracle VirtualBox, or VMware Workstation, or Microsoft Hyper-V. All these options are available. But if you're already on Windows, you can enable WSL. Okay, so let me also type it here. Okay, so you can enable the Windows feature, which is called Windows Subsystem for Linux version 2. Okay, Windows Subsystem for Linux. Once it is enabled, then you go to Microsoft Store. Okay, then you can install Linux as an application from here. See how many options are available. You can install Ubuntu Linux operating system, Kali Linux. Okay, and Debian Linux. Debian Linux is also one distribution. Okay, what else? That's it. Okay, so one way is to directly install Linux as an application from Windows Store. Second is install the WSL version of CentOS or Red Hat. Again, from CentOS, you'll get to know how to install the WSL version. Okay, it's very easy. Okay, but still, again, for this, you have to first of all get into the settings, enable the Windows feature, reboot the laptop, and then install it. Okay, right. Okay, so but the best method of installation is using VMware Workstation or Fusion. Why? Because with that you are actually selecting everything, how to install. You have the freedom to select the options, set the values. Okay, so I'll show you when I start the installation. I'll show you. Okay. All right. So once the ISO is downloaded, the third step is to create the virtual machine. Create the virtual machine. Okay, which means on this VMware Fusion or VMware Workstation, you will create a skeleton of the virtual machine. You will allocate the CPUs, let's say 2 CPU, 2 GB RAM, right? 20 GB of hard disk, and then you will attach the ISO file. Once the ISO file is attached to this virtual machine, you reboot the machine, and the OS installation will start. Then you have to press next, 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 like that. Okay. You have to select the language, select the networks, enable the network, few more things, set the passwords and all. Okay. And the operating system will be deployed, right? Okay. There is a message. Okay. So the question is, can I install Linux directly on the system, not a virtual machine? Yes, it is possible. In that case, you need to make sure that you have a bootable media. Okay, so your laptop, these modern laptops don't have the DVD drive, right? So what you have to do is you have to create a bootable USB pen drive. Okay, so bootable pen drive using the application called Rufus, RUFUS. Download Rufus. Okay, it will ask what is the ISO, the same ISO you can use. Then it will ask what is the pen drive. Let's say the drive letter E is your pen drive. Next, click on start. It will take maybe 10 to 15 minutes, and your pen drive, which is on E drive, okay, this pen drive will become bootable. Then you have to boot your laptop with this pen drive. Okay, make sure this pen drive is the booting device. All right. Uh, Restart, boot with pen drive, and you will see the same installer, the operating system installer. Okay, and then you can install Linux operating system. Okay, if you want dual boot, you can also do dual boot. Right. So, but again, if you have a spare device, then only do that. Okay. All right. Guys, only 4 minutes are left, and I need to start another class at 9 p.m. So, okay, never mind. Tomorrow we connect at the same time. We're going to start with the same steps, uh, install the application, workstation, or Fusion, download the ISO, and create the virtual machine. Okay. So let me quickly show you about the ISO first of all. Okay. Because we have just 4 minutes left. Okay, so simply type CentOS. Okay, maybe on Google search, just type CentOS download. Here it is, centos.org/download. It's not .com, it's .org. Okay. All right. Okay, as you can see here, CentOS Stream version 10 and version 9 both are available. 10 is selected automatically. By default, it is selected. And then you have the various options like what to download. Download this installer ISO file for 64-bit systems, ARM systems, IBM Power systems, or IBM Z systems. Let me tell you, last two are not applicable for us. These are applicable for servers which are used in the companies, old servers, not new, old servers. Okay. ARM64, this architecture is used by Snapdragon Elite processors for laptop and Apple Silicon, Apple M1, M2, and so on. All these use ARM64 architecture. Intel CPUs use 64-bit. AMD CPUs use 64-bit. So first one is 64-bit. AMD, Intel, both CPUs are applicable. Okay, so your laptop might be having Intel CPU or AMD CPU, it doesn't matter. You simply go with this option, 64-bit, and you have to download what? The ISO file. Forget about RPM's cloud containers vagrant for now. I'll tell you about these things later. Okay, you have to download the ISO. Same way for Apple, M1, M2, all these CPUs, ARM64. So this is the option. Mirrors is like if in the background, if one link is not working for download, another link will be used for the download. Okay, so just simply click on mirrors, it will start the download. So for me, the first option is applicable. Click on mirrors and see this. Immediately you get to see save as dialog box. Okay. The good thing is I've already downloaded it. It's already there in D drive downloads. Here it is, CentOS Stream 10 latest. Okay, so it's already there. Although I downloaded it last year, But once I install the operating system, I will update it. So it will be then latest version. CentOS stream 10.1, 10.2, whatever is latest, it will be updated to the latest release, right? So simply click on it. Again, as I said, it's approximately 9 to 10 GBs. It's going to take some time, right? Right. Same way for Red Hat Linux. For Red Hat Linux, as I said, you have to first of all register and then download. So let's talk about all these things tomorrow. Okay, so we'll start with straight away with the virtual machine deployment. Okay, and obviously, once the virtual machine installation is in progress, we'll cover the remaining things like the background of Linux, how Linux is, the major player. Sorry, how Red Hat is the major player in the IT right now. How many products, like for example, Red Hat, Ansible again from Red Hat. Okay, OpenShift again from Red Hat. So we are in the Red Hat ecosystem. We are learning the Red Hat ecosystem. It will help you a lot. Okay. Okay, guys. So I have 16 GB laptop. Yeah, perfect. 16 GB RAM is more than enough. All right. You will be able to practice everything till OpenShift, everything. Okay. All right, guys. So let's connect tomorrow, same time, and we'll proceed from here. Okay. In fact, we'll resume from the VM deployment, right? Thank you guys for joining. I hope you're able to, understand what I said in this 1 hour. And and guys, feedbacks are welcome. If you want me to speak a bit slow or bit fast, let me know. Okay, I'll adjust. Okay, thank you guys. All right, guys. So this is it from my side for today. Let's connect tomorrow and let's continue. Till then, bye bye. Good night. Well, you're welcome, guys.